Today we're going to continue factoring trinomials, but we're going to make it where a is greater than 1. So when we look at example 1, it's 2x squared minus 5x minus 3. We always check for a GCF to make sure that we can't factor something out to make the trinomial smaller. There is no number that divides into 2, 5, and 3 besides 1 and itself. Those are all prime numbers, so we're good to go. If you need to, you can continue to label that a equals 2, b equals negative 5, and c equals negative 3. We would make our x, a times c above, b below. A times c, 2 times negative 3 is negative 6. b is negative 5. Since AC is negative, we're looking for multiples of 6 that subtract to 5. Because if I look at multiples of 6, I have 1 and 6 and 2 and 3. And some of you guys would select 2 and 3. But I need them to multiply to become a negative number, so either one of them has to be a negative, and if I subtract these two, the difference is 1. So we would select 1 and 6, because we know that 6 minus 1 is 5. Then we just have to decide which one is negative. If I were to look at this, my 5 is negative, so that means that my bigger number needs to be negative. So I have 1 and negative 6 as the multiples I would choose. When we had where a equals 1, we didn't have a different denominator, so we really got away from the habit of dividing by a. It is imperative that we do it now because our a is no longer 1, so our values will change. So if I write my side numbers now, we have 1 over 2. 1 over 2 doesn't reduce, it just remains 1/2. But if I write negative 6 over 2, it reduces to just negative 3. We already know how to write binomials with just an integer because our denominator is 1. The only thing that changes with this one is that our denominator is 2, so that means our leading coefficient in the binomial for this factor is going to be 2. When I rewrite it, it becomes 2x, and this is a 1, and the whole term is positive, so it'd be plus 1. And like I said, we've already written answers in binomials from here. My denominator is 1, so instead of writing 1x, it's just x, and then minus 3 because it was negative 3. So it's the same process that we've been doing. We just have to definitely divide by our a now. That is not just 1. Let's go ahead and do another example together. Example 2. Let's do 4x squared plus 8x plus 3. Again, if you need to label A, B, C, go ahead. We would make our x, a times c, b below. A times c would be 12, and my b is 8. AC is positive this time, so I'm looking to add the multiples to my bottom number, which is 8. 12's multiples are 1 and 12, 2 and 6, 3 and 4. Looking at the multiples, the only two that add to 8 are 2 and 6. Placement of 2 and 6 doesn't matter, just like on all the others. We just need to make sure that we take these two side numbers and divide them by 4, which is our a. So we would have 2 divided by 4. This is where we want to reduce. We know that 2 over 4 is equivalent to 1/2. It reduces. And 6 over 4 also reduces by 2, and it would become 3 over 2. So before I even rewrite my answer, I want to think this through. Both of my leading coefficients in my binomials will be 2. They're both positive, so they'll be separated by plus signs, and my integers or my constants will be 1 and 3 in the binomials. Final answer, leading coefficient, 2x plus 1, and 2x plus 3. If you need to check your answer to make sure that you did it correctly, you could always distribute both terms into the other binomial or do the area model that we've done with multiplying to check that it works back out to the quadratic that you started with. So here's one for you guys to try for yourselves. Two x squared plus 15x plus 7. I'll draw the A times C and B below like you should be to start off the problem. And go ahead and pause it so that you can work on it separately. Should have done 2 times 7 because it's A times C, which is 14. My B is 15. Need multiples of 14, which are 1 and 14, and 2 and 7. The multiples that add to 15, since it's positive, is 1 and 14. Then we need to divide both of them by 2. So 1 over 2, we know, again, doesn't reduce. It's 1/2. Not all of them will have 1/2 in your answers. It just worked out that these 3 that we've done so far do have 1/2 in them. And then we have 14 over 2, which reduces to simply just 7. Let's go ahead and write our answer into 2 factored binomials. So that would be the leading coefficient of 2x plus 1. And we have a leading coefficient of 1 on this one because our denominator is 1, so we could simply just write x plus 7. Let me go ahead and give you guys another practice problem so that you guys can work it out on your own and double check it with the video. 3x squared plus 10x minus 8. Go ahead and pause again. On number 2, you should have done 3 times negative 8, which is negative 24. Our B is 10. Anytime it's negative, we're looking to subtract our multiples to the bottom number, which is 10. So we would have 24, 1 and 24, 2 and 12, 3 and 8, and 4 and 6. Again, some of us might have automatically selected 4 and 6, but this is not the case for this one because we would need the 24 to be positive for it to be 4 and 6. It is negative, so we're looking for the multiples that subtract the 10, which if I look, 2 and 12 subtract the 10. So 2 and 12. Ask yourself which one needs to be negative for it to be positive 10 when we subtract. The bigger number needs to be positive, so that would make the 2 negative. Write our two side numbers over A. So we have negative 2 over 3, which does not reduce. So I'm just rewriting it to make sure that I did check to see if it can be reduced. And then 12 over 3, which reduces to 4 over 1, or 4. This binomial is going to be separated by a minus sign because it's a negative term. This one will be separated by a positive because it's positive. So when we go ahead and write our answer, 3 is our leading coefficient in the first binomial, x minus 2. Unless you wrote it with your negative 2 and 12 here, don't worry about it. Order of multiplication doesn't matter, so you could write these binomials in either order. And then our second one, for this one, our denominator was 1, so it is x plus 4. Anytime you want to check to see if you factored correctly, you could distribute it back through or do the area model to make sure you get it back up to the multiplication of what you started with.